Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. So this is section 2.1 with the title Rates of Change and Tangents to Curves. So let's start with the average rates of change and secant lines. Here we have a definition. The average rate of change of y equals f of x with respect to x over the interval from x1 to x2 is defined by delta y by delta x, which is equivalent to f of x2 minus f of x1 divided by x2 minus x1. And this can be written as f of x1 plus h minus f of x1 divided by h, where h is the difference between the 2 points x1 and x2. H here should not be 0. To understand more, let's refer to this figure. So this figure shows the graph of the function y equals f of x, which you see it, the blue colored curve. Okay, so this is the graph of the function y equals f of x. Now, if we select 2 points on the graph, the first point is P with the coordinates of x1 and f of x1, because this is x1, the coordinate of the point, and the value of y at this x1 can be found by replacing x1 in the function, which is f of x1. And the second point Q at x equals to x2, the value of the function will be f of x2. So these are the coordinates of the second point. So the line connecting these 2 points is called the secant line. So the secant line is the line that intersects the graph of the function at 2 points, like this line which intersects the graph of the function at P and the Q. So this is called a secant line. Okay. Now the average rate of change of this function is defined as delta y by delta x. What is delta y here? Delta y, the length of this vertical dashed red colored line, delta y, is the difference between f of x2 minus f of x1, because the line from this point Q to the x-axis is f of x2, which is the value of y at x2. And this line, the dashed line, from P to the x-axis is the value of the function at x1, which is f of x1. So if we consider the difference between these two lengths, the length of the line, which is f of x2 minus f of x, will be delta y. And delta x is the difference between x2 and x1, because x2 is measured from the origin, x1 is measured from the origin. So the difference between them, delta x, is x2 minus x1. We will call it h. Okay? So delta y by delta x, or delta y by h, and delta y here is f of x2 minus f of x1. Now, if we replace x2 by x1 plus h, because if x2 is measured from 0, from the origin to this point x2, then we can say x2 is equivalent to x1 plus h. So that's why you see here in the definition, instead of f of x2, we replace x2 by x1 plus h. So now the average rate of a change, which is delta y by delta x, we can write it as f of x1 plus h minus f of x1 divided by h. Remember that h is the difference between the 2 points, x1 and x2. And f of x1 is the value of the function at x1. F of x1 plus h is the value of the function at the second point x2. Okay. So this is called the average rate of change. So if you find this ratio delta y by delta x, you will be able to find the average rate of change. In fact, this average rate of change, we call it also the slope of the secant line. So the slope of the secant line is equivalent to the average rate of a change of y equals f of x from x1 to x2. So there are two names here, the average rate of a change, which is given by this definition, and it's also equivalent to the slope of the secant line. So I can write here, I can add here also the slope of the secant line. I'll use the symbol m, okay? So m is the slope of the secant line, the slope of the secant line. Okay, the slope of the secant line that passes through the 2 points P and Q. So this definition has two names. Either we call it the average rate of a change of the function from x1 to x2, or the slope of the secant line that passes through the 2 points P and Q. Now, let's define the slope of a curve, the slope of the curve. What we mean by the slope of the curve is the slope of the tangent line to the curve. Tangent line. Tangent line is different from the secant line. So what is the tangent line? For the circle, if we have a circle like this, the tangent line, which is here the line L, we call it tangent line. So this tangent line to the circle at point P, that is the line passes through the point P perpendicular to the radius of the circle OP. In other words, this tangent line to the circle touches the circle only at one point. So this line should not intersect the circle at 2 points, otherwise it will be called the secant. So the tangent line is the line that touches the curve of the circle at one point, like point P. So we'll call it the tangent line. This is for the circle. How about the graph of the function that is not circle, like in this figure 2.3, the blue colored one? This is not a circle, it's a curve. So what is the tangent line at point P, let's say? Well, to understand this, let's start with the secant line. If we have 2 points like point P and point Q, and there is a secant line passing through them, because this line intersects the graph of the function at 2 points P and Q, so we'll call it a secant line. Now, let me move Q along this path, along the curve, approaching P. So if we move from this line, I'll number it as secant line number 1. If Q is getting closer, then we will move to line number 2, and then to line number 3. All these lines are called secant. Why? Because they intersect the graph at 2 points, this point and P, Q and P, this point and P, this another point, intersection point and P. Number 4 here, a secant line intersect the graph at 2 points also, Q at this point and P. See, this Q is getting closer to P. Now, when Q coincides with P, means when Q and P are the same at the same location, then the secant line becomes this red colored line, which touches the curve of the function only at one point, point P. Again, so when points Q and P becomes together, coincides with each other, then this secant line becomes a tangent line because it touches the curve of the function at only one point, that is point P. So here, for the secant line to be a tangent line, the point Q has to approach very closely to point P. So the definition here, the tangent to the curve at point P is the line through P whose slope is the limit of the secant slope as Q goes to P from either side. So when the secant line becomes a tangent line, means the two intersection points becomes one point. So hence we will say the secant line becomes a tangent line. So if we refer back to the definition here of the slope of the secant line, so if we find the limit of this term as h goes to 0, because when the 2 points becomes become very close to each other or coincide with each other means delta H will become, or H will become 0. Imagine that if this point is coming closer to P, Q is coming closer to P, then X2 and X1 will become 1 point. So H here now is very close to 0, very, very close to 0. So if we consider the limit of this term as H goes to 0, means we are calculating the limit of the secant line that becomes a tangent line. Okay, so here in the second figure you can see approaching Q is approaching P from the other side, from down. Okay, so in both figures here, if Q is approaching P, means H is in the definition is approaching 0, then the slope of the secant line becomes the slope of the tangent line. So here we can have this definition. The slope m to the curve of the function f of x at a point p equals, or p with coordinates x0, y0 is defined as m, this is the slope, which is the limit of the slope of the secant line as h goes to 0. So we'll call this the slope to the curve of the function or the slope of the tangent line. Okay? The slope of the tangent line. In other words, we can say the slope of the tangent line is equivalent to the limit of the average rate of change as h goes to 0. Let's have this example. Find the slope of the parabola y equals x squared. This function is called parabola at the point P with the coordinates 2 and 4. Okay, so one point here with the coordinates 2 and 4. These 2 and 4 are the values of x0 and y0 in the definition. Okay, and then after we find the slope to the curve of this function, which is the slope of the tangent line, we need to write an equation for the tangent to the parabola at this point. So to solve such a question, what you need to write here, you need to write first x0, which is 2, and y0, which is 4. These are the coordinates of the point in the definition. So you can write here x0 and y0, okay? Because we are going to use this definition, so we have x0 and y0. y0, which is f of x0, f of x0 is the value of the function at x equals 0, we can write y0. So we need to replace these here for x0 and f of x0. And h here, what is h? Okay, h, we'll keep it as it is. So this is f of x0 we needed. How about f of x0 plus h? H is unknown, we keep it as it is. F of x0 plus h means we need to substitute in the function instead of x, x0 plus h. So this becomes x0 plus h squared. You can expand this bracket as x squared plus 2x0 h plus h squared. Okay, now you calculate the slope m from the definition. You need to find the limit as h goes to 0. Okay, this is so I have to substitute in the definition. So f of x0 plus h, this term, which we wrote just now, x squared plus 2x0 h plus h squared divided by minus first, minus f of x0. This is f of x0, it's 4, right? 4 divided by h. And we can substitute actually x0 by 2 because we know x0. So we can say this is limit as h goes to 0. So we can substitute x0 by 0 square plus 2 multiplied by 2 multiplied by h plus h square minus 4 divided by h. And this will be limit as h goes to 0. Here 4 minus 4 is 0, and we will have 4h plus h square divided by h. You can see in the numerator we can take h as a common factor, and that common factor, like this, take h as a common factor, then we will have 4 plus h, and down we have h. So this h will be cancelled with this h, and the remaining will be lim 4 plus h as h goes to 0. And we did learn how to find the limit of such function by direct substitution. So if you substitute h by 0, you will get 4. So the limit here is equivalent to 4. So which is the slope of the tangent line to the curve of this function at p with the coordinates 2 and 4. So at x equals 2, the slope of the tangent line is equivalent to 4. So if you graph y equals x squared, you will find that at this point with the coordinates 2 and 4, the slope of the tangent line is 4. Now we need to write an equation for the tangent line to the parabola. So the tangent line is a straight line, and how to write the equation of the straight line? We have to use a formula. You learned it a long time ago. The formula says the slope equals y minus y0 over x minus x0. So for this straight line, we know the slope. Just now we calculated 4. This is equivalent to y minus y0, which is 4, divided by x minus x0, which is 2. You just solve this equation, rearrange it, then y minus 4 equals to 4x minus 8, and then y will be 4x minus 8 plus 4, that is minus 4. So this is what we call the equation of the tangent line. It's a straight line, and this is the equation of the straight line. So this is the answer of the second part of the question. Okay? So this is the way we find the slope of the tangent line, okay, from the limit of the average rate of a change. So actually this is the average rate of a change, 4 plus h, and if we consider the limit of this average rate of change as h goes to 0, then we can find the slope. Once we find the slope of the tangent line, we can find the equation of the tangent line. So we have to remember this equation, m equals y minus y0 over x minus x0. Now here we have some equations. We can follow the same steps that in the previous example to find the slope of the curve at the given point P. When we say the slope of the curve, we mean by that the slope of the tangent line to the curve at point P, and then we find the equation of the tangent line. So what I will do, I will solve the first question, question number 7, and then you have to do the rest of the questions at home. So again, what we will do is, for question number 7 here, we have to identify first x0, which is 2. We have to identify y0, which is, we can write f of x0, which is given as 1 here. If the question does not give us this value of y, we can find it by substitution. If you substitute x by 2 here, you will get f of x1, f of 2 equals to 1. So, but the question here gives us the value. So this is what we need from what we need to write in the definition. We need also to write f of x0 plus h, okay, which is actually f of 2 plus h. You can start substituting 0 from here. And how to find this? this is the equation, this is the function f of x, y is f of x. So we need to substitute here x by 2 plus h. So we will have 2 plus h square minus 3. And you need to expand this. When you expand it, it becomes 4 plus 4h plus h square minus 3. And then you can write this 4 minus 3 is 1 plus 4h and plus h square. Okay, now the slope is what? M equals lim as h goes to 0. You have to remember this definition. F of x0 plus h minus f of x0 divided by h. So now you do the substitution. So this is lim as h goes to 0. Now f of x0 plus h, we found it, which is 1 plus 4h plus h square minus f of x0, which is 1 here, okay, divided by h. See, 1 will be cancelled with 1, and then we will take the h as a common factor, and will be cancelled with the h below, and then ultimately you will have the limit of 1 plus 4 plus h. So 1 minus 1 is 0. Take h as a common factor, cancel it with the denominator, then we'll have 4 plus h. So the limit here as h goes to 0 is equivalent to 4. Okay? So this is the slope of the tangent line at the point 2 and 1. So again, you have to find the slope, the equation of this tangent line. So we have to use this formula, m equals y minus y0 divided by x minus x0. So here m is 4, and this y minus y0. y0, we said it's here is 1, and x0 is 2. So minus 1 over x minus 2. Okay? So y0 is 1, and x0 is 2. Yeah. So simplify this equation, then you'll have y minus 1 equals 4x minus 8, and then y will be 4x minus 8 plus 1, that is minus 7. So this is the equation of the tangent line to the curve of this function at x equals to 2. Okay? So at this point, with the coordinates 2 and 1, there is a tangent line. Its slope is 4, and its equation is y equals 4x minus 1, 4x minus 7. So this is the solution of number 7. So there are another 4 questions. So I expect you to solve all these questions at home. Okay? So that's all for this topic. I will see you again in the class. Okay, bye-bye. Assalamu alaikum.